Hello everyone, welcome back to the channel. Now in this video we are going to actually implement the balance factor method. We are going to know if our balance factor is in a balanced state or not, okay? Because this balance factor is going to tell us if your tree is in a balanced state or not, okay? How do we understand using this balance factor if your tree is in balanced state or not? So first of all, this is the formula to calculate balance factor, okay? Height of your left tree minus height of your right tree, and that's how you get your balance factor. Okay, now if balance factor is greater than 1, okay, that means your tree is left heavy, and if your balance factor is less than -1, then your tree is right heavy. So this is how you understand if your tree is left heavy or right heavy. Okay, if it becomes 2 or it becomes -2, that's where you know your tree is in not in balanced state. Okay, so we are going to use the same formula and we are going to implement exactly the same. Okay, no difference. So let's implement that balance factor so that we know if your tree is in balanced state or not, and where actually that imbalance is there. We are going to see that as well. Let me calculate it right there. While insertion only we are supposed to calculate the balance factor. So int balance factor, if we have taken a variable that is int balance factor. Now as we have just now discussed about the formula, that is height of left child minus height of right child. Basically whatever is the height of your left subtree and whatever is the height of your right subtree, we do a subtraction there and we calculate what is the balance factor there for that particular node. And then what we do, if your balance factor is greater than 1, okay, that means the current root node, whatever value is there, that node is so greater than 1. That means it's a left heavy, that node is left heavy, because you get 2 when you have a lot of nodes at imbalanced state in the right side. That's when it's a left heavy. Else if balance factor, come on, why I'm getting box layout again and again. If balance factor is less than -1, that's when you know, okay, come on, don't do that. Okay, that's correct. That means your root dot value is right heavy. Okay, so this is a simple logic to calculate if your tree is left heavy or right heavy. You calculate the balance factor. How do you calculate the balance factor? The height of your left subtree minus height of your right subtree. And that's how you calculate balance factor for each of the node. Now if you talk about this particular tree, okay, so this we talked about earlier that this is a right skew tree. Okay, so which node is exactly right heavy? That is this 10. Okay, so this is a right skew tree and 10 is the right heavy node. So on 10 we are supposed to perform the left rotation. Okay, so first we are supposed to get key 10 is the right heavy node. So if our logic is correct to calculate the balance factor, we are supposed to get 10 is right heavy. So let's run the program and we are getting 10 is right heavy. So our logic to calculate the balance factor is working perfectly fine. Okay, if you change these values, let's say if you make this 10, this makes 30, this makes 20 and this makes 10, that means now it became a left skew tree. Now your 30 is left heavy. Okay, now if I run it again, you will get 30 is left heavy and you're getting it. So that means your balance factor logic is working perfectly fine. Now to make it more readable, what we can do, we can extract these conditions. Okay, now how do we extract? Let's create those methods. Private boolean is left heavy. We are going to pass the AVL node there, and here we are going to control now here we are going to write the logic. Return height of node dot left child minus height of node dot right child if it is greater than 1. See, this is the same logic that we have written here. Okay, now once we are done extracting this logic, right, you won't be needing this int balance factor height calculation and all that, so you can actually remove it. Now we have this left heavy method. Let's create a right heavy method. Is right heavy. I have intentionally copy pasted to show you what are the changes I'm doing. I have changed the name and the logic. What is going to change? This is going to be less than -1. Okay, let's add that semicolon there. Okay, so we have the logic now. Still we are actually repeating this line, right? Let's extract this as well, which is refactor. I know I'm using some shortcut. Okay, thanks to IntelliJ. Private int balance factor. Yes, IntelliJ is really intelligent. It is asking key we can replace this logic at 2 places. Yes, go ahead and replace it. So what it did for both of our methods, left heavy and right heavy, it found out that 2 places is where we are using that logic, and it replaced that, and the logic is still the same. If it's left heavy, calculating the balance factor is greater than 1 or not. In the right heavy, it is calculating if the balance factor is less than -1 or not. Same logic we are supposed to use here. So is left heavy root node, and again here is right heavy, again the root node. That's it. The logic is still the same. All we have done is some refactoring, nothing else. So with this particular logic 10 20 30, we are supposed to still, this is a right skewed tree and 10 is right heavy, and we are still supposed to get the same answer that 10 is right heavy, and we are getting it. So our logic, even after refactoring, our logic is perfect. So now what we are supposed to do, if 10 is right heavy, right, we are supposed to actually perform the left rotation so that our tree comes back to the balanced position. So we're actually going to check what are the rotations that we have to perform, and we are going to perform those rotations. That's all I wanted to show as part of this video. See you in the next one. May the source be with you.